I am Anil Kumar, and in this video we will summarize even and odd functions for the parent functions. The question here is determine whether the parent functions are even or odd. So I hope you remember what are even functions and what are odd functions. So let's summarize that part. Even whenever we say that f of x, or rather f of minus x, is equals to f of x, then it is even. However, if f of minus x is equals to minus of fx, then it is odd. That is one part. And the second part is that even function is symmetric about y-axis, right? It's symmetric about y-axis, and the odd function has a point symmetry, right? So it is symmetric about origin. So that's the point, origin, right? 0, 0. So these are the two major characteristics which help us to figure out whether the function is even or odd. If these characteristics are not matched, then the function is neither. Okay, so let's begin from the very first parent function, which is a straight line. So let me make a small sketch and then we'll figure it out, right? So straight line, as you know, that divides, and it is symmetric about the origin, right? So it is symmetric about the origin, and so we say this is an odd function. Is that okay? This is one way of saying it. The other way is, what is the value of f of minus x? So if I write f of minus x, I will get minus x, which is equals to minus of fx. So this is another way of saying it. What we are trying to say here is that if I take a value 2, for example, then I get a value 2, right? However, if I take minus 2, then I get minus 2 as the result, right? So if the x value becomes negative, y value also becomes negative, correct? So that is what we mean when we say f of minus x is minus of fx, correct? So that is what it is. Okay, let's look into this absolute function and see whether that is even or odd. So in absolute function, if we sketch this function, what do we get? Well, this is always positive, so this line flips upwards, correct? So it is kind of like this. As you can very clearly see, it is symmetric about the y-axis. That is to say that if we have a point on the left side, then we have its image on the right side. Do you see that? So in this particular case, if we say f of minus x is equals to what? So if I substitute minus x within the brackets, I get absolute x, and that is equals to f of x. Now since f of minus x is equals to f of x, this function is even, right? So this function is even for us. And you also see that it is symmetric about the y-axis. So that is how you could figure it out. So you have to provide this reasoning for each and every function and then write it down. So x squared, it's your choice. You could sketch it. So if you sketch it, you know it is symmetric about the y-axis, correct? So this is even, correct? So this is even. You can also substitute minus x, and you know minus x whole square is also equals to x square, and therefore we know f of minus x is equals to f of x, right? So that ways you could prove it. Perfect. Now sine x. Now sine x is a function which is kind of like this, right? So it's a sine wave, right? It's a sine wave like this. It goes on and on. Now as you can see, the sine function actually starts from 0, right? And if you see, it has odd symmetry. If I take some degrees here, then the value is plus, and on the other side it is negative, and it is symmetric about the origin, right? And therefore we can summarize sine x as a function which is odd, correct? So sine x is an odd function. So this is an odd function, and here what we notice is that sine of minus x is equals to minus of sine x, right? And that makes it odd. So sine x is an odd function, correct? So let me just draw a line here to differentiate between all those things. That's good. Let's look into the other two functions also, q. So what is minus x whole cube? Minus x whole cube is minus x cube, or we can say f of minus x is equals to minus of f of x, and therefore this becomes an odd function also. And the last function here is 1 over x. So if I have minus of 1 over x, it is minus of 1 over x, correct? And therefore f of minus x equals to minus of fx, and this function is also odd function, correct? Now you could always sketch all these functions and check for yourself how do they look like. Now 1 of x is symmetric about the origin, you can see like that. So it has a point symmetry. Do you see that? So all these points are symmetry about the origin. So that is kind of a summary on even and odd functions, right? Now your question here is, derived from all this, if I write the function f of x equals to cos x, now tell me if this is even or odd, right? For cos x, the situation is that this is the graph, right? So this is the graph for sine function. We consider only sine function as parent simply because if you translate, it becomes a cosine function. Do you see that? And clearly you can see what type of function it is. So your question is, f of x equals to cos x, is it even or odd? And here is the most difficult question on this exercise, and that is f of x equals to x minus 2 whole square. This function, is it even, odd, or neither, right? So these are your test problems. You just look into these and figure it out. I hope this video helps you to understand the concept and also gives you something challenging. Thank you and all the best.